All right, part 2 here. Sorry about that. Second video, I'll just upload it, or I don't know. Maybe I can splice them together. We'll see. I really got to see about recording to a memory card when I do this because I keep running out of space on my phone. But anyway, so let's look at one more example here. One more, a little more complicated one. I'm just going to draw it in the middle here. It's kind of like the ones on the bottom of the page where there's two different motions happening. So our position versus time graph. Oh, I think there might be one like this. Let's see. I'm going to do something a little bit different. Let's say it starts out here and moves this way. All right, so this is a nice straight line, right? But then, let's say it then curves like this. All right, let's see what this means. Let's try to analyze this now. So we've got our velocity in time axis and our acceleration versus time axis. All right, so now this is getting more complicated, right? So we start out at a big positive position. So if I was to try to draw a motion map of this, right, it'd be like something starting out here. And it's decreasing in position as time goes on. So that means it's moving back towards the origin at a constant speed. And how do I know it's a constant speed? Because the slope of the line is constant for the first half. And then, once it gets to about half, I don't know, 2/3 of the way through the motion, the slope of the line gets steeper. So that means it starts speeding up, right? But it's heading in the negative direction. So what happens is the arrows start getting longer and it starts moving faster. So it moves with a nice constant V, and then it starts accelerating. And it's doing it in the negative direction. It's starting with a big positive position, and then it's heading back towards the origin. It's losing position as time goes on, and then it starts really losing it fast once we get to that dashed line. All right, so I'm going to transfer this dashed line to both of these graphs. All right, so I'm going to show you something here. Curved, flat, curved, linear, flat, 0, 0. All right, this is the order. Oh, let me move my phone a little bit so you see all those on there. All right, curved, linear, flat, 0, 0. This is the order in which the shapes of the lines go. So if the first graph is curved, if the position is curved, velocity is linear, acceleration is flat. If position versus time is linear, the velocity must be flat, the acceleration must be 0. If the position is flat, that means it's not moving. Therefore, the velocity would be 0 and the acceleration would be 0. So, we have a constant negative slope on the position versus time graph. So that means we have a constant negative velocity. If we have a constant negative velocity, that means we have no acceleration because we have a constant velocity. So we've got this constant negative velocity to start off with, but then the velocity has to increase. It has to get more negative. It has to get bigger in the negative direction. So as the slope starts to get bigger, like a bigger negative number, then what happens is the velocity actually has to go like this. It actually has to get more negative, a bigger negative number. So this is negative, positive, positive, negative. All right. And now the acceleration, so this is curved. We got curved, linear, and then this one's got to be flat. But where is it flat? Is it a positive acceleration or a negative acceleration? Well, it's accelerating to the left. The direction of the acceleration is to the left. So that means it's a negative acceleration. I can also tell that because the slope of the line of the velocity versus time is a negative constant slope, so therefore it's a negative constant acceleration. All right, so that one's a little more complicated. Watch this back, see if this can help you get a start on that stacks of graph worksheet. We're going to do a lot of it in class, but you can refer back to this video for help. All right, thanks a lot. Talk to you later.